Hey everybody, it's Byron Hendricks here again with Hendricks Consulting Engineers. We're a mechanical, electrical, and plumbing engineering company, as well as commissioning in Central Texas, actually based out of Round Rock. I've got a bachelor's in architectural engineering and a master's in mechanical engineering. I'm a second generation professional engineer. I've been in the industry over 25 years, and I just wanted to bring you guys some information I get asked about a lot. So today we're going to talk about relative humidity. It's one of the things I keep getting asked about over and over. Facilities guys are asking me, construction guys, building operators, and sometimes it's just, people who want to know a little bit more. So Kinsey, the camera girl, is going to bring me some props here, and we're going to talk about two different examples on how we can talk about relative humidity. So, you could go back and black out because you think, oh no, physics. I cannot talk about physics anymore. I fell asleep in physics. Well, I talk a lot faster, and hopefully I can cover this information in a way that you can understand it and get a little bit out of this video. So we're going to go over two examples today. Kinsey's bringing me a couple different containers. They are in the wrong order, but that's okay. We will reorder them. All right. So, two examples. First example, different temperatures, same amount of water. All right, so each one of these HCE glasses is filled with the exact same amount of water. Now, each one of these different empty buckets represents a different temperature, noted on the red line here. So I'm gonna go back and forth just to make this easy. So one of the things we gotta know about the psychometric chart is a couple things. Water, more water is up, less water is down. That's first thing. Down at the bottom, we got temperature. Hotter and colder. All right. Then you see all these goofy lines. Okay, and there's one over here. So all these curved lines, you're going to see them labeled right here. Relative humidity. Okay. So the farther we are this way, 10%. Less humidity. This last one over here is 100%. Also known as the dew point. So as we get colder, for the same amount of water, it's going to be higher relative humidity. We'll show you that here in just a second. Okay, so we're going to start on the red line. So we got that red line with those dots on it. Okay, so we've got different temperatures, fixed amount of water. So the way they label it here is called the humidity ratio, but we're going to use it as fixed amount of water. Same thing. Okay, so on the hotter temperature, we dump the water in. You can tell by the fullness, let's call it 15%, right? So this would be 15% relative humidity at a given temperature. And the hotter the air, the more water it can hold, because as things get hotter, the molecules expand and there's more room for water. So it has a bigger carrying capacity. So the colder we get, the less it can hold, right? Same amount of water, say that's 85, or let's say that's 100. Let's say this is 85. So now you've got out of the total, 15%, out of the total, maybe 30%. Okay, let's do this one. This one's quite a bit colder. That's why it's a smaller bucket. Now you're looking, oh man, this is 85, 90% full. So for this experiment, we would call that 85 or 90% relative humidity. Now, if we get really, really cold and it's humid, this is what happens in your air conditioner. As we fill up, I'm gonna do this so we don't make a mess. As we fill up the tiny temperature bowl with water, we find out, uh-oh, too much. Okay, so what does that mean? Well, that's what happens in your air conditioner under a cooling coil. That's how you get moisture out of the air. Different video, different day. So what you should notice here is big bucket, smaller bucket, smaller bucket, smallest bucket. All the exact same amount of water. In this case, probably about 8 ounces, okay? And so what happens is the colder we get with the same amount of water, higher relative humidity. Okay, so let's look at a different example. Now, that was the red line. Now let's look at the blue line. So what the blue line is gonna represent, I arbitrarily picked 80 degrees, okay? So we're gonna say our 80 degrees, the amount of water it can hold is this blue cup. Let me get these all emptied so they're the same. Okay. Now, we have 4 examples, 80 degrees. So this is how much water 80 degrees can hold in this example. So we're going to start at the bottom, 10%, 30%. I need a little more water here. 75%, and this last one, I'm going to fill her all the way up. So in this example, all the same temperature, starting at the bottom, less humidity, a little bit more, and totally full. And so what you're starting to see, where'd my pen go? We'll use this one. So now we're doing the blue line. We're going up. So it's barely full. It's got a little bit more. It's got a little bit more. Man, it's really full. And so what this represents is same temperature but different amounts of humidity. And so the point is it's all relative. It's relative either to the temperature and the amount of water, or the temperature changing, you have the same amount of water. Either way, the relative humidity changes. And so if you look right here on our chart, you'll see them labeled 10, 20, 30, all the way up to 100. So just remember, the colder it gets, the less water you can hold, big, medium, smaller, smallest. And for a given temperature, the more water you add, the higher the humidity. So that's going to conclude us talking about relative humidity today. If you've got any questions, comments, suggestions, you think I messed it up, I could do it better, I want you to leave me a post in the comments. I love all your feedback. You can find us on Instagram at Hendricks Consulting Engineers. You can find us on Facebook, Hendricks Consulting Engineers. You can find me on LinkedIn, I'm Byron Hendricks. You can find us on the World Wide Web at www.hcengineer.com. Don't forget to like, share, and subscribe our videos. If you got any other topics you want me to cover, just shoot me in the comments, and we'll see what we can get to. Until next time.